So we're going to take another detour. We were talking about functions and then polynomial functions, linear, quadratic. You'd think we'd go on, but I don't know why we keep taking these detours. I don't know. The book just gets thrown together hodgepodge, I guess. We're going to talk about rational and radical equations. Again, we could do this anywhere. I don't know why it just sets up in disorder, but let's just do it in whatever. So here's a typical example, right? We're going to solve a problem like this. And you'll see this is rational, right? It's a polynomial divided by a polynomial, and that's what rational is. All right, so how do we go about solving this? All right, let me just move the problem down here. Okay, I'm going to come up with a method that we're going to use for all these problems, even when they're more complicated. And then we also can use when we do log equations involving logarithms. Okay, so one method. I don't like 50 different ways. Put everything on one side, right? I'm just going to move this term. I don't know what this junk is on here. Put this on the other side so it's equal to 0. Right? I want to move it to the one side so it's 0. All right, and again, we're going to do that when the expressions are more complicated and when we do logarithmic equations involving logarithms. Okay, so it's going to be a way we're going to do problems. Make it equal 0. Now I need a common denominator, right? In this case, it's fairly straightforward. This is the first problem. We'll get more complicated. And this is the least common denominator, right? Again, we'll see. But I'm just putting in the steps. Notice it's a very ordered process. That's what I'm trying to emphasize here. And it's going to generalize to every, other problems, right? Same process. And this is rational, and that's why it's solving rational and radical equations. It's a polynomial divided by a polynomial. And we talked about what polynomials are, right? This is A is 1, B is 0, C is minus 25. Again, you don't have to write that down, but you should see that's a polynomial. And of course, that's a polynomial, right? So that's why they were solving a rational equation. So it's rational, there's an equal sign, and it equals 0, so we're solving it, right? So this is a rational equation. Now, again, this is the algebra. I'm not trying to introduce you to thousands of rules and thousands of rules. These are the standard. A over B is undefined when B is 0. I mean, it's pretty basic, right? A over B is, and B is the bottom there, the denominator. So we're undefined when the bottom, again, I don't know where all this junk is coming from. When x not equal to 5, right? So we need the third point. We need to know where we're undefined. Where we're undefined. Now look at the top. And again, this is a common theme. We can factor the top like this. Now, if it's quadratic, you always have the quadratic formula available. But just see if you can factor it. Just factor the top. Right? So where B is 0 is where it's undefined. Where A is 0, the numerator, is where it equals 0. Right? A over B equals 0, provided A is 0. Provided A is 0. So for us, we have this. Now notice, how do we go about solving this? Well, now we have A times B is 0. So, okay, I set the numerator to 0. Now I have A times B is 0, provided A is 0, B is 0. You see, it's the same couple of basic rules that come up all the time. A, right, A is 0. And, or, right, possibly both, or, or 0. B is 0. Okay, so the factors will go to 0. And there we go. X equals 5, X equals minus 5. Now you always need to check this because we're not defined at 5. All right? We're not defined at 5. This equation is not valid when X equals 5. So we have to cross that one off the list. And there you have it. Okay, and it's a good idea to check your answer. As I say, and for most problems in this class, you can actually check your answer. Plug it into your original one. Go to the original one and make sure everything checks out. They have to be equal on both sides. Right? They have to be equal on both sides, and it checks out. So I know I have the right answer. Okay, now this is a more typical problem, right? This is a non-trivial one, but the same exact steps will apply. Again, this is rational, so let's go through this. What's the solution? Same procedure. That's the point. The procedure I made isn't just for one gimmick problem. It works for everything. And again, it'll work later on. And so again, I don't like 10 ways of doing one thing. So I'm just going to start down here. And there's going to be a lot more algebra to this, and I'm just sorry about it. This is just part of what we have to deal with. Right? So I'm just going to take this, and I'm going to move it to the other side. Right? I just move it to the other side so it winds up equaling 0. That's all I did. Now, this is what I have in the bottom, and I need a least common denominator here. Right? So write down what it is. Why don't you take a moment, see if you can do it. Write down what you have here. And you think this is the problem. You think you do this and it's not right. Bam. Not right. It's too much. If you use that as to get as your common denominator, it's too much. It'll make it really difficult. In fact, I've never ever seen anyone get it right on the test that made this kind of choice. If you want the least common denominator, so what you want to do first is you want to factor this term. You want to make sure everything's broken down to its factors. Now again, you could use the quadratic formula to get this, but I would, again, it factors in a straightforward way. So now look at it again. Everything's broken down, and see what the least common denominator is, and you see it's this. Right, I can get this. So that's the idea. That's easier to use. Now we just have to work that in so everything has that as a denominator. Right, I get the x plus 3 from the first term. Right, that's for first term. I get the x from there. And notice I get the x minus 3 from there. I already have the x plus 3, so I don't need to include it. Right? I just need all the terms represented. So that's my least common denominator. So notice what I have to do. I have to work that into all the terms. So see, I have to put it in and take it out. It equals 1. So I get the correct denominator. Right? And then I do it on the second piece, the second term. Right? So I have to make sure I add it in so I get the correct denominator. And I do it for the third term. And again, there's a lot of algebra, and I'm sorry about it. I know this is just painful, but you just have to persevere through these problems. So I get the common denominator again. Okay, so notice in each of these terms, I have the same denominator. That's the key, right? All these terms have exactly the same denominator. So now what I want to do is I just want to clean up the top, right? You just want to clean the top up. Just multiply it all out, clean up the top. Clean up the top, right? Just multiply it all out, clean it up. Multiply it all out, just clean it all up. Right? So that's the next point. Okay, now I needed to run out of space, so I need a new page here, right? So I'm just going to come over here with a new page. So the ... are just on the previous page. I just can't keep everything. And this is just the same one I had before. So everything has the same common denominator, right? So I can combine it, right? Same common denominator here, so I combine it here. And then I have this term from there, from the first term. This is my plus, my second term. Notice it's a minus sign here, so pay attention to this stuff. Here's my third term, minus sign the third term. Okay? I like to distribute the minus sign because I find that people make algebra mistakes. So what I suggest to you is if you have a situation with a minus sign, just distribute it. Put it inside of everything so you don't lose track of that. It goes to both terms, right? It goes to the first term, and this is where people forget. It goes to the second term. Okay, so just be careful with that. So now I have the plus and plus, because this way you don't lose track of the minus signs. I just find it better. Okay? Now I'm going to drop the brackets, just drop the brackets, and now I want to combine everything. I mean, I know this is not the easiest thing. There's a lot of algebra. So, okay, again, I need a new page, right? So this line is where we left off. So what I want to do is I want to put all the x squares together, and I want to put all the x's together, and then I want to put all the constants together, right? The x squared, the x to the first power, the x to the 0 power. So all the x squares I'm going to put together over here, all the x's here, and then the constant term here. And you just combine it all. I factored out the x squared, so I can combine those. I factored out the coefficients in front of the x, and I factored out the constant. And you just do the algebra, the 3x squared minus 15x and minus 18. Okay? So notice the top is just a polynomial. Now we're in a position where we can start moving. We got the common denominator, right? Everything's combined. So let's see what we have. I have a over b. Again, same procedure. It's undefined provided b is 0. Right? Provided b is 0. Well, what's my b? B is, well, the denominator. So when do I know if b is 0? Well, now notice I'm a times b times c equals 0. Right? Again, it's the same rules you're using over and over again. Try to spot that. It's all about setting it up to do the same thing. So a is x, b is x minus 3, c is the x plus 3. You just plug it down into it. A is 0, b is 0, c is 0. And you can just solve it. X is 0. Right, there are my three terms. X is 0, x is 3, and or x is minus 3. Okay, so again, there's a reason why things happen. It's not random. So this is undefined when x is 0, 3, or minus 3. So we don't want this to be minus 3, 0, or 3. Right, it's undefined at those values. Okay, so we have to come back and check later. This equation is not defined at these values. Okay, so I know where I'm undefined. Now how about the top? I have to factor out the top. Right, I have to factor the top. And again, it's a quadratic. You could use the quadratic formula, but if you can factor it, just factor it. Now, if you look at this, take out the 3, right? The 3 is the obvious thing. It's a, and then it's simpler to factor. Right? Remember, when you use the quadratic formula too, you take out the a. So a is 3 in this case, right? So when does a fraction equal 0? A over b equals 0, provided a is 0. Right? Provided a is 0. Again, I can set the numerator equal to 0, but I can divide by the 3 because the 3 is not, is greater than 0. And again, we have a times b equals 0, a is 0, b is 0. Right? So we set the factors to 0, and there's your x is 6, x is 1. Now I need to check, right? Do I have to throw away any of those values? Make sure you're defined there. So I don't have any problems, so they're my values. Right, they're my values. Now you want to go back and check that it works, right? Plug in your 6 everywhere you have an x to make sure it works and work it all out. You'll see that you get 1 equals 1. And if you plug in minus 1 for x, you check and you also get 1 equals 1. It all just comes out to be 1 equals 1 if you sort it out. Okay, so again, there's another example where you can check your work, and that's a big deal. Yeah, that's my answers. Now, how about a radical equation? This is a radical equation here because there's a square root. Square root is a radical. Okay, so how do you do this? I'm just rewriting it here. Make sure you have to have on one side is only the radical. It can be a square root, it can be a cube root, it can be whatever it is. The radical has to be on one side and all the other junk has to be on the other. It doesn't matter. It can be anything. All the other junk that isn't the radical goes on the right. So your radical goes on one side and everything else goes on the right. Whatever it is, there can be more than one term, whatever it is, put it on the right. So to get rid of the radical, I square it, and that's square both sides. You have to do both sides. Okay, so I have to square both sides, and this is the rule. Remember, a square root is a half power. So I have to do square it. If it was a cube root, I have to do cube it, right? Power 3. Okay, and that's your rule. Now again, we're getting into more specialized rules, but this is the game for radicals. So I get rid of the square root. I have the 4x plus 1 on the one side and 9 on the other. And you just solve it. X is 2. Subtract 1 from both sides, divide by 4. And again, I want to point out, you always have to check. I think there's one in the homework that doesn't have a solution. So you always want to check. Just plug your x into 2 and see what you get. Right? 3 minus 3 is 0. Notice the square root is not plus or minus 3. The square root of 9 is 3, right? I mean, again, I see people make mistakes on the test. They'll say it doesn't work because it's plus or minus 3. The square root of 9 function is 3. Okay, so be aware of that. Right? Square root of 9 is 3, not plus or minus 3. Okay, so in this section, what are you doing? With respect to rationals, you should be able to find the solution of a rational equation, and you should be able to find the solution of the radical, just the examples we did. Okay, that's what you need to do in this section. Make sure you're comfortable with that. Again, there's more of it as algebra here, and just be patient, but they should have the same form. Don't reinvent the wheel every time. Try to follow the procedures. Okay, guys, well, good luck.